the next thing I want to illustrate is how to construct a superconducting magnet. And if we want to construct a superconducting magnet, we need to have a multiply connected superconductor like a donut or a superconductor with a hole in it, and we can cool it in a magnetic field, and if we remove the magnetic field, the screening currents will persist in the superconducting ring indefinitely, and we've essentially formed a superconducting magnet. So I will illustrate this with a toroidal shape. So essentially we have the same solution region as previously, or the air region, and I'm using boundary conditions on the toroid here. So this circle would be rotated about the z-axis here, forming a toroidal ring, essentially. On the end caps of the model, I have 0 vector potential. On the side of the model, I have 0 vector potential, and on the top end, I have 0 vector potential. What I need to do is establish a uniform field. So on the side region, I'm going to give this a vector potential of 1. This is on the cylindrical side. On the bottom region, I'm going to have 0 tangential field, and on the top end cap, I have 0 tangential field. Okay, now I have the correct boundary conditions to give me a uniform field, and I have a field cooled, putting 0 normal flux on the toroid here. Okay, so you can see that the field is going to be slightly enhanced inside of the toroid. If I make an XY plot of the field, once again is slightly enhanced in the central region. We can make a finer solution if we want to get a smoother curve here. Okay, now what I'm going to do is turn off the external magnetic field. Furthermore, I'm going to assign a vector potential value to the superconducting ring. Okay, we're looking at basically the vector potential here, the flux function. And I'm going to assign this value to the superconducting ring. So instead of 0 normal flux, I'm going to give it a vector potential that it already has, 0.2387 approximately. Okay, now I'm going to turn off the magnetic field. So on the cylindrical boundary and on the end caps, I have 0 vector potential. Now, when I solve this problem, what we have is a flux that is trapped inside of the superconducting ring when we turn off the external field. So we've cooled the ring in a finite magnetic field, and when we turn off the magnetic field, the screening currents are going to flow to preserve the total flux in the ring. So the total flux in the ring will remain constant when we switch off the magnetic field. So we've essentially constructed a superconducting magnet.